Welcome to this course on electric circuits. In this lesson, I will give you a quick overview of the course, that way you have a better idea of the things that you will learn. I will show as well some of the preparations that you need to do in case you want to use the simulation tools to make your own models. But before we start, please allow me to introduce myself. My name is Leonardo Laguna Ruiz, and I'm a PhD in electrical engineering. I work at Wolfram Research developing System Modeler, which is the simulation tool we offer. Some years ago, and a bit accidentally, I started a small company where I combined my passion for music, electronics, and simulation. I design synthesizer modules, which are a combination of actual hardware and simulations running on small processors. I started working with electronics at a very young age, and over the years, I gained a lot of practical knowledge that allowed me to build circuits from schematics I found on magazines or the internet. But I was not able to create my own circuits until I started studying the theoretical aspects of electrical engineering, like the analysis methods and equations that define the behavior of the components. With this course, I want to present to you all those basic concepts and show you some of the tricks that made it easier for me to understand them. Even when this course is more focused on the theoretical aspects, I will show you multiple applications, especially in the later parts of the course where I present multiple circuits that are used in analog synthesizers. The course is split into 4 parts. In the first part, I try to create a mental model that will help you to intuitively understand how circuits work. In the second part, we go back to the fundamentals, where you will learn the physical concepts and the basic laws that explain how circuits work. The third part covers the analysis methods. This will give you the tools to analyze and understand the behavior of the more complex circuits that we will cover. The last part focuses on learning operational amplifiers and their applications. This is the most extensive part of the course, and we will learn the basic building blocks to create more complex circuits, like the ones used in analog synthesizers. To enjoy this course, you don't need to have neither System Modeler or Mathematic installed, but if you want to create your own simulations or interact with the notebooks of this course, you do need them. You can get trial versions of the software in the Wolfram site. The software is available for Windows, Mac, and Linux. All the diagrams and simulations you will see in this course are made with System Modeler. That allows me to create interactive simulations like this one, where I can change parameters and see the results. You can explore all the models directly in System Modeler. We have a library of models that should be included alongside with the notebooks. This library is called EE Basics, and it contains all the models classified by part of the course. If you want to modify them, I highly recommend you to create a copy of the model and make your changes. One important thing is that System Modeler requires a C++ compiler to work. When you run System Modeler for the first time, you should get the instructions to install it. This course does not cover how to use Mathematica, neither System Modeler. If you want to learn more about them, you can explore the catalog of courses, tutorials, and books available in the Wolfram site. For example, by selecting the Modeling and Simulation category, you can find all the System Modeler courses. Let's start with the course. I hope you enjoy it and you learn something new.